Short about the experiments done at SINTEF. So let me see. A bit of background. The metallurgical industry is one of the doesn't just produce metals but also CO2. So we need to do something about it, and substituting carbon with hydrogen is one of the few options. So we are looking into this in the HAlMan project, and moreover, we will try to use the raw materials that we have more efficiently. So maybe we can use some waste materials in this project. Now I'm returning a bit back where Jafar where Jafar left us. So which elements are we are involved in this project? Well, usually we produce manganese with carbon, and as you can see in the elegant diagram, carbon is a very strong reductant, so it's possible to reduce manganese with carbon. Hydrogen is not such a strong reductant. We can reduce iron oxides to iron with hydrogen, but we cannot fully reduce manganese ore to manganese or ferromanganese metal. So when we're running it in hydrogen, the iron which is present in the ore will be reduced or the iron oxides will be reduced to iron, but the manganese will be reduced to MnO. If we want to go further, we need aluminium, so as we do in this project to do the further reduction. So also here we are in the HAlMan project. We're looking at 3 ways to do the pre-reduction. We have I will tell about the SINTEF rotary furnace, and then there's the Calix drop tube reactor and the vertical reactor at Mintec. Okay, the pilot site at SINTEF in Trondheim. This is our smelting hall, and in the middle there somewhere you can see the rotary furnace. If we get some closer up, it looks like this. Is what we call it the plasma rotary furnace. The capacity is up to 500 kilos, and we have previously used this furnace to reduce iron oxides to iron. We have reduced the iron in bauxite, and we have also reduced the iron in bauxite residue. So in this project, it's manganese ore, which is the raw material. What is a bit special about this furnace is the plasma torch. It's an old SINTEF invention from the 80s. These are 2 pieces of graphite, and in between there we put it on a high there's a high voltage and a low current. So there's a plasma there of up to 300 kilowatt, and this means that we create, because it's a graphite torch. We create a reducing atmosphere, and we can run it with different gases. So we can also run it with hydrogen, and then we create a very reducing atmosphere in this furnace. So during the project, we have crushed non-sounding malm from South Africa to sizes lower than 20 millimeter. We ran the furnace with 300 liter per minute of hydrogen, up to 350 liter minute of hydrogen. That sounds like a lot, but this is like less than 2 bottles per hour. The campaigns lasted up to 16 hours, and 3 campaigns have been performed. Well, in practice, we have lots of thermocouples on the outside of on the outside of the furnace. So we have lots of readings from from the furnace, but we are not really sure what the temperature is inside the charge. So now and then we stop the furnace and we do a temperature measurement with a thermocouple into the charge. You can see this on this picture where Odin is doing such a temperature measurement, and they are in the picture like the crosses. So you see that the temperature in the charge is about 200 degrees more than what we measure with the thermocouples on the outside. We also do like Leco analysis, of course, with the ore is like 0 hours here, and then it's like 33% of oxygen in the material, and we do a number of measurements after a while, and then we see that the oxygen drops. It's there's lots of scatter in these measurements, but yeah, it goes down to like 22%. The reference here at 900 are some results of the small lab scale experiments where we are 100% sure that we have reduced that what we can reduce. Also, we do some microprobe, and in the microprobe we observe iron particles, and that confirms that like we have gone from MnO2 or Mn2O3 down to MnO and iron. So then we know that we have run the furnace long enough, and we have the phases that we want to have. Also, when we do XRD, here these are 7 samples from the furnace. So from sample 1 is in the start and sample 7 is in the end. And in the end, when we've been running, we start to see that the iron phase comes up in XRD. So then we know that we have reached the equilibrium. Well, the results, we have run 3 campaigns and have produced enough for the aluminothermic reduction that is being done at Mintec. So that's well all that I have to say here.